Now I will be showing you how to convert decimal numbers or numbers of base 10 to the binary number system or base 2. So base 10 to base 2. So first, we have two major points or key points to the process of converting this one. So that is successive division of the number to the radix or to the base. This time is 2 until the quotient becomes 0. Letter B, the remainders are the digits of the resulting binary. Okay, so we try with 189. So successive division. So we have 189 divided by the radix. So this time it is in binary, so divide that by 2. So you have 9, then you have 18, you have remainder 9, and then can be divided still to 2. We have 4, so that becomes 8, and then you have a remainder 1. So take note of that remainder, and then 94 divided by 2. So you need to successively uh, divide the quotient to 2 until the quotient becomes 0. Then you have 2, so this becomes 4, and then you'll be given by 8, and then you have 1, 4, and then 7, so you have 14, then 0. And then you have 47 divided by 2. This becomes 4. Oh, sorry, that is 2. Then this one's 4, and then you have 7. Then this is 3, so you get 6, and then your remainder 1. And then you have 23. Then you have 1 and 2 and 3 and 1 by 2. And then, okay, then 11 divided by 2. Your answer will be 5. So you get a remainder of 1. And then 5 divided by 2. You get 2. So you get 4. Then remainder 1. And then you have 2 divided by 2 is 1. So you get 2 and then you have 0. Then you have 1. So that is divided by 2. You cannot stop at 1 because it is not yet on 0. So this becomes 0 times 2 is a 0. It becomes 1. So you stop here when your quotient becomes 0. Okay, and then this first remainder is called as your least significant bit, and this one is your most significant bit. And then how to read the resulting binary number, you should be reading this one backward. So your answer should be 1, 0, 1, 2, 1, 1. Okay, and then that is 0, 1. Okay, and then so that is the resulting binary number. So you can say that the answer is 189 of base 10 is equals to 1, 0, 1, 1, 1, 1, 0, 1 of base 2. Okay, so that is your answer. Okay, okay, how about the if your decimal contains a fraction part? So this is the integer part and this is the fraction part. So let's do this one separately. So you need to separate the 25 and the 0.50. Okay, so separate the integer, separate the fraction. So So what we do for the integer, it is the same on example number 1. So that is successive division. So you have 25 divided by 2 is 1, 2. That is 5. This is 2, 4. Then you have remainder 1. And then 12 divided by 2, you have 6. So 12, you have 0 remainders. 6 divided by 2, so that is 3, and 6, you have a remainder of 0. Then 3 divided by 2, that is 1. So you have a remainder 1. So 1 divided by 2, so that is 0. So you have 0 remainder 1. So read it backward. You have 1, 1, 0, 0, 1. So try to check your 25. Okay. Okay, so review if you are catching up. Okay. And then so try to retain that answer, and then we do the fraction part. In doing that fraction part, it is because fraction only of that decimal. Okay. So in doing the fraction part, you write 0.50 because that remains with our number. Then you should be able to multiply that by 2 and then get your answers. So what will be your answer? So 0.50 times 2 is 1, right? Then you have 1.00 to be exact. And then you should be able to get again the decimal 0.00 times 2. Now it becomes 0.00. And then your answer should be, and then there's nothing more you can really do because this becomes 0 as we progress. So you combine. So how to read the decimal? So the whole number in these places are your binary digits when you are converting your fractional part. So meaning that is a fraction of 2 only. So your number should be 11,001 dot 1, or you can actually write triple zero or so on, or you can also write 1 and so on. It's just the same. So your number, your 25.50 on base 10 is equals to 11,001 the point 1 base 2. So that is how to convert your decimal number system to binary number system with base 10 to base 2 with integer part and fractional part. That's all.